Alright, so hopefully today you've gotten a grasp of how to simplify rational expressions, because what we're going to go over tonight is complex fractions. And complex fractions are essentially the sum of or difference of a rational expression in the numerator and the sum or difference of a rational expression in the denominator, otherwise known as fractions within fractions. So let's start with 1 and we'll walk through it. And we're going to do a few examples here. So we'll do, I think, a total of, actually I just have 2. We'll do 2 for right now and take our time with it. So if there's any questions that you have, please make sure you note it. These have a long process to how to do them, but the process does not change no matter what it looks like. Okay, so here's an example of a complex fraction. So we have a rational expression on top and we have a rational expression on the bottom. Now there's a few different ways to go about doing these. So I'm only going to show you one method. And this one method is the one that most math teachers agree is the simplest or quickest method. But there are others out there. So if you're working with someone and they're doing it differently, doesn't mean they're doing it wrong or you're doing it wrong. They just might be using a different method. So one of the first things you want to do is, again, factor all denominators. And what I mean by that is all of these little denominators factor if they're not already factored. So in this case, all of these are already factored, so we don't have to do that step. Okay, second thing we're going to do is we're going to find the LCD. And so when we find the LCD for this one, we're going to look at all the denominators and see what they would be if we multiplied them all together. So x plus 1 has to be in my common denominator. X minus 2, we have to account for that. I already have the x minus 2 accounted for, and I already have the x plus 1 accounted for. So this is my LCD. Now, unlike the simplifying of the rational expressions we just did, we're not going to get a common denominator for all of these and add them together. We're going to do something a little different with this LCD. And this is where the methods start to differ. So no matter what, these are the first 2 steps no matter what method you do. This third step, you're going to multiply each fraction by the LCD. So that means I'm going to take this fraction up here, multiply it by x plus 1, x minus 2. I'm going to take this fraction and multiply it by x plus 1, x minus 2. And then each one on the bottom, x plus 1, x minus 2. And then x plus 1 times x minus 2. Now make sure you notice I'm not multiplying it to top and bottom because that would be getting the common denominator. I am just multiplying the fraction. So all of these are over 1. So when we go to multiply them, we're really only multiplying it to the numerator, not to the denominator as well. So when we go to multiply, I notice that on this one, the x plus 1 on the denominator is going to cancel with the x plus 1 on top. That's what we want to happen. That's why we're multiplying by the LCD. So when I multiply these, I'm really only going to have 7 times x minus 2 left in this first fraction. For the second one, the x minus 2 is going to cancel with the x minus 2, leaving me with 3 times x plus 1. And so what you should notice is that in the numerator here, we've gotten rid of the fractions. The denominators have both canceled and they're both 1. So now we're down to just a polynomial on top. The same thing is going to happen on the bottom. So x minus 2 is going to cancel with x minus 2. So we have 4 times x plus 1. And then on this one, we'll have x plus 1's canceling, leaving us with 3 times x minus 2. Again, since the denominators canceled, the denominators are 1, so we're just left with the polynomial. So just to walk through it again, start by factoring your denominators, find your LCD, and then multiply each fraction by the LCD. Then we're going to simplify. So let's see, distribute the 7, distribute the 3, and then on the denominator, distribute the 4, and distribute the 3. Combine like terms on top. Combine like terms on the bottom. Oh, I even made that mistake. I'm sorry. My 1 crossed my minus sign, that making it look like a plus. So this should actually be a minus here. I thought something looked off. I'm sorry. So this should be, we distribute the negative 3, making it negative 3x plus 6. So that's my bad. I shouldn't have. Let me redo that one, just so it all looks right. So that was a minus, but I put my denominator of 1 to accidentally cross it. Okay, so back on track. 4x minus 3x will give us just x. 6 plus 4 will give us 10. Nothing can reduce top to bottom, so we're done. So again, the process is a little bit longer than ones we've done before, but you're going to follow these same steps the entire time. So we're going to do one more example. I'll number this one number 1 though. 2 over x 2 over x plus 1. So when we, oh, you can't see that. Okay, so when we look at this one, this might look a little bit simpler than the one before, but for some reason it's the simpler looking ones that seem to cause issues. So that's why I wanted to make sure we went over one of these. So again, I'm going to factor my denominators first. Can't. There's nothing to factor. So x is already factored, x plus 1 is already factored. There's nothing to do more. Next, I'm going to find my LCD. So my LCD, I'll have an x and an x plus 1. Then I'm going to multiply each fraction by the LCD. So I'm going to multiply x times x plus 1, and remember that's over 1, x times x plus 1, and again remember that's over 1, so we're only doing these to the denominators, or we're only doing these to the numerators, I'm sorry. So when I actually multiply, x will cancel with x, and I'll have 2 times x plus 1 left. On the bottom, x plus 1 will cancel, leaving me with 2 times x. So before I go and distribute anything, the way that these look already is factored. So on top, I have 2 times x plus 1. So the GCF is 2. On the bottom, I have 2 times x. So I can actually simplify this by canceling out the 2's giving me a final answer of x plus 1 over x. If you distributed the 2, you would then just note it for your simplifying step. You would just have to take it back out again. So if you notice it beforehand, it'll save you a step. If you don't, you should be able to get there eventually when you multiply it through and then you see that you have to take out the GCF. Okay, so that's kind of a more basic looking one. The more complex looking ones will have the adding and subtracting, but again, just follow the steps. And even if you, so if you can factor and find the LCD, but these two are where you start struggling, that's okay. Just make sure you let me know. But I want you guys to try as much as you can, or if you have questions, please note it. If we need to do another one before we start tomorrow, let me know. I have a few more that I can dig up. But yeah, so make sure you note any questions and let me know tomorrow.